Today we are making a start in a new module, Module V3, which is about solving equations. Now, you might think we already solved equations in Module V2, and that's correct. But we're going to learn a new method for solving different kinds of equations. We are starting today with a small introduction. On the screen you can see a few equations. On the left, these equations, they come from the previous module, Module V2. Which we could solve using the card method or the shield method. Now, in Module V3, the equations look like this, slightly different. Take a moment now to look at the equations and see if you can spot what the main difference is between these equations and the ones from the previous module. Now, the correct answer is that the variable x that we need to calculate in the equations appears more than once in the equations on the right hand side. So the shield method or the card method doesn't work here because we have an x over here and over there. So we're unable to use the shield method here. So we're learning a new method to solve these kinds of equations, and that method is called the balance method. In activity 1 of Module V3 on numworks, you see this. The first thing you see is this. Here in this screen is the equation that we need to solve. 4 times x equals x plus 6. Now imagine that this equation is represented by a scale, and the scale is in balance. On the left hand side, you see 4 bags that each weigh x. We don't know the weight of these bags, so we call their weight x. On the right hand side we have one of those bags that weighs x, and we have 6 loose, let's call them marbles, that all weigh 1. And as I said, the scale is in balance right now, so this together weighs the same as that. And what we need to do is figure out what the weight is of one of those bags of marbles. It's very important to realize that each of these bags that has an x on it, they all weigh the same. So this x is the same number as that one. We just don't know what it is yet. What we can do is remove things from the scale, but if we do so, we have to make sure that the scale stays in balance. So if I take away this bag right here, then you see that the scale is off balance right now. But if I take one bag of x away from the left hand side, the scale is back in balance. Now the equation has changed because right now on the left hand side I only have 3 bags of x, and on the right hand side I only have 6 loose marbles. So the new equation changes. It becomes 3 times x, 3 times x on the left hand side, and on the right hand side we remove the bag of marbles, so we just have the 6 loose ones. This is the equation that we have right now. 3 times x is equal to 6. This is not so difficult anymore. We know what x has to be. 3 bags of x weighs 6, so 1 bag of x has to weigh 2. The equation is solved correctly. We can check it by removing the last 2 bags from the left hand side and also removing 4 of the marbles, and you see that the scale goes back in balance. If we go to the second activity, we see a different kind of equation. 3 times x plus 4 is equal to 2 times x plus 7. Again, it's represented by a scale that is in balance. On the left hand side, 3 x's, 3 times x, and 4 loose marbles plus 4. On the right hand side, 2 bags of marbles, 2 times x, and 7 loose marbles. The first step is always to take away as many bags of marbles from both sides as you possibly can. So here I can take away 2 bags of marbles, and I can do the same on the other side. Now the scale is back in balance, And the new equation is x plus 4, because I haven't done anything with the loose marbles. Oh. And on the right hand side, I've taken away those 2 bags of x, but those 7 loose ones are still there. So this is the intermediate step. X plus 4 is equal to 7. Now, if I take away 1 loose marble here, I can do the same over there, and the scale is back in balance. I can do that a few more times. Here 1, there 1, and it's in balance. I can do that again, take away 2 here and take away 2 there, and now I know that x has to be 3, but you might have already seen that before. The equation is solved correctly. In the third one, we get this equation, 4 times x plus 2 is equal to 3 times x plus 6. As you can see, we still get the scale, but all of the things that we could put on the scale that represents the equation has been left out. So the first thing that we can do is put the things on the scale according to the equation. On the left hand side we see 4 times x plus 2. So we can put 4 bags of marbles on the left hand side. 1, 2, 3, 4. That represents 4x. And plus 2 means that we have to put 2 loose marbles here. On the right hand side we see 3x plus 6. So we put the 3 bags of marbles on the scale, as well as 6 loose marbles that all weigh 1, 4, 5, and 6. And as you can see, the scale is in balance right now. Alright, so the first thing to do always is to remove bags of marbles from both sides. As many as you can. So in this case I can take away 3 bags of marbles here, and I can also take away 3 bags of marbles there. So now the equation that I have is no longer 4 times x plus 2 equals 3 times x plus 6. It has become 1x, so just x, and plus 2 loose marbles is equal to 6 loose marbles, 6 loose marbles on the other side. So this is the intermediate step. And now to figure out what x is, we can take away these 2 loose marbles here and take away 2 loose marbles there as well. The scale is back in balance, so x has to be 4. There we go. Let's move on to number 5, because something interesting happens here. The equation that we need to solve is 6 times x plus 7 is 55. And because 55 is such a large number, they chose not to make 55 little marbles, but they chose to make bigger squares that weigh more. So this is 50 and this is 5. We also have ones of 10 down here below. The method for solving it is the same. We have to try to keep the scale in balance, and the first thing we can do is see if we can take away any loose numbers on both sides. So right here I have 7 and here I have 55. So if I take away 7 here, that's all fine, but I need to take away 7 on the other side as well. And if I do that, then 55 becomes 48. So what I can do is, I put all of the ones in front of it, but should be okay. 10, 20, 30, 40, 45, and 3 of 1, 2, and 3, and the scale should drop back in balance, as we can see right here. So that means that 6 times x is the same as 48. Now, if 6 times x is equal to 48, I can figure out what x is by dividing by 6. So 1 bag of marble, x, has to be the result of 48 divided by 6. Now, 48 divided by 6 is 8. Let's see, that's correct. So, well, basically we're done, but to make it the image complete as well, we can remove all of the 10-gram boxes, and now I have 8 left. So x equals 8 in this one. Moving on to the next one. Here they represent negative numbers by the yellow circle. As you can see, the equation that we have to solve is 5 times x minus 4 is equal to 3 times x plus 4. So the minus 4 here is new. We see on the scale 5 bags of x and 4 of those yellow circles that represent minus 1. So these 4 is minus 4 together. And that has the same weight as 3 bags of x plus 4 loose marbles, as I keep calling them. Now, the first step is the same. Take away bags of marbles, as many as you can from both sides. So here I can take away 3 bags of marbles, and I can take away 3 bags of marbles on the other side as well, and then the scale will still be in balance. So the new equation that represents this situation is 2 times x minus 4 is equal to 4. 2 times x minus 4 is equal to 4. Now, if I take away one negative number, then I have to add 1 on the other side to keep the scale in balance. I can do that 4 times in total, so 1 away there, and I have to add 1 there, and again, and once more. Done. So now we see that 2 times x is equal to 8. And now it's easy to solve. If 2 times x is equal to 8, then 1x has to be equal to 4. 1, 2, 3, and 4. Yes, there we go. So x equals 4. That's the solution to this equation. There's one more that I want to do, and then we're done. 6 times x plus 6 is equal to 2 times x minus 2. Again, we get the yellow circles that represent negative numbers. The first step is the same. Take away bags of x, as many as you can from both sides. I can take away 2 from the right hand side, and I can also take away 2 from the left hand side, and then my equation becomes 4 times x plus 6 is equal to negative 2, because all of the bags of marbles are removed. Now, if I take away these 6 loose marbles on the left hand side, then I have to take away 6 loose marbles on the other side as well. I cannot do that because there are no marbles there, but what I can do is add negative numbers there. So taking away 1 here means I have to put 1 negative on the other side. And I can do that 6 times in total. And each time I do it, the scale will go back in balance. So these last 3 need to be removed. And then the negative balls on the right hand side. And now the scale is back in balance. So the corresponding equation that I have right now is that 4 times x is equal to minus 8, because there are 8 of those negative yellow balls on the right hand side. Now, if 4 times x is equal to minus 8, then I have to divide by 4 for the last step. So x has to be equal to the result of minus 8 divided by 4, which is minus 2. The equation is solved correctly. So 1x, one of those bags, is equal to 2 of those negative yellow balls, so minus 2, and the scale is back in balance. I hope this was clear. You can do the rest of these exercises yourself, and I will make another video explaining activity 2 and activity 6. Good luck!